Now today here comes the next topic to find all the zeros of a polynomial when sum of its zeros are given. Now here you can see that in this question it is a biquadratic polynomial since its degree is 4. So it will have a 4 zeros. So out of the 4 zeros, only 2 zeros are given and rest of the 2 zeros we have to find it out. So first we will find out the divisor. The 2 zeros are given. So required divisor is given by the formula x square minus sx plus p, where s is the sum of the roots. So root 2 minus root 2 into x plus root 2 into minus root 2. As we know that the sum is alpha plus beta and product is alpha into beta. So here alpha plus beta, so alpha plus beta, root 2 minus root 2, alpha into beta, that is product, so alpha into beta, which gives us, this cancels out and x square minus 2 will be our divisor. Now with this divisor we will divide the given biquadratic polynomial. So 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2, and divisor is x square minus 2. Since here root 2 and minus root 2 are the zeros, and with the help of these two zeros we have formed the divisor, so this divisor will be 100% factor of this biquadratic polynomial. It means that when we will divide it, the remainder must be equal to 0. So first we divide it, let us see, 2x to the power 4 upon x square, 2x square, 2x square into x square, 2x to the power 4, 2x square into minus 2, minus 4x square, minus plus, minus 3x cube plus x square plus 6x minus 2. Now minus 3x cube divided by x square, which gives us minus 3x. So second term minus 3x minus 3x cube minus into 3 into minus 2, that will become here plus 6x. Now plus minus, this cancel out, left out with x square minus 2, x square by x square, that becomes 1 plus 1, so x square minus 2, so minus plus, this cancel out. So whenever we are calculating the rest of the zeros of a biquadratic polynomial and we are forming a divisor, in that case of division of polynomial, the remainder must be always equal to 0. So now for calculating the rest of the zeros, we got here quotient as 2x square minus 3x plus 1. Quotient is 2x square minus 3x plus 1. So for calculating its zeros, we just take q of x equal to 0, that becomes 2x square minus 3x plus 1 equal to 0. By splitting the middle term, 2x square minus 2x minus x plus 1 equal to 0, minus 2 minus 1 equal to minus 3, minus 2 into minus 1, which will equals to 2 into 1, 2 positive. So 2x common, x minus 1, minus 1 common, x minus 1, x minus 1 common, 2x minus 1 equal to 0, x minus 1 equal to 0 or 2x minus 1 equal to 0, x equals to 1 or x is equals to 1 upon 2. So two of the zeros which was given in the question was root 2 and minus root 2, and rest of the two zeros as we have calculated here 1 and 1 by 2. So the zeros are, all the zeros are root 2, minus root 2, 1 and 1 by 2. So as we know that it is a biquadratic polynomial, and I told you earlier that in case of a biquadratic polynomial there will be a 4 zeros or roots or solutions. So these are the 4 zeros and 4 solutions, that is root 2 minus root 2 which was given earlier in the question itself, and 1 and 1 by 2 that we have calculated it. Now let us see the second question of the same variety. Find all the zeros of the given biquadratic polynomial if two of its zeros are under root of 5 by 3 minus under root of 5 by 3. Now it is a radical as well as the fractional form. So required divisor, the same formula will be applicable, x square minus sx plus p. So x square minus sx root 5 by 3 minus root 5 by 3 into x plus root 5 by 3 into minus of root 5 by 3. As we know that the sum is given by alpha plus beta and the product is given by alpha into beta. So alpha plus beta, it is minus sign, so it will be cancel out, and here product, so x square minus 5 by 3 it will come root into root, this will be 5 by 3. So now if we take LCM here, as it is a constant value is a fractional, we will take the LCM. In the previous question it was x square minus 2 only, but here the constant is fractional form. So now we take LCM, we get 3x square minus 5 upon 3, that can be written as 1 by 3 into 3x square minus 5. Now when we divide a polynomial, given polynomial, our divisor will be this term only. We will not take this coefficient as a divisor. So our divisor will be here only this one, 3x square minus 5. That is only the difference between the previous problem and this problem. Let us now divide. So 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. So 3x square minus 5. So 3x to the power 4 upon 3x square, which gives us x square. So x square, 3x to the power 4 minus 5x square. So minus plus, this cancel out, 6x cube plus 3x square minus 10x minus 5. Now 6x cube divided by 3x square. 6x cube divided by 3x square, which comes 2x. So here it will come plus 2x. Now 2x into 3x square, 6x cube, 2x into minus 5 minus 10x, which comes minus here plus, this both the terms cancel out, remaining terms 3x square minus 5. Now 3x square divided by 3x square will give you 1. So here comes the plus 1. Now 3x square into 1 will be 3x square, and 1 into minus 5 will be minus 5. So change the sign, and again the remainder will come 0. In each and every case, in such problem, the remainder will be always 0. Now for calculating the other two zeros of this biquadratic polynomial, we take this quotient. The quotient is q of x is equals to x square plus 2x plus 1. For calculating the rest zeros, for zeros we take q of x equal to 0. So x square plus 2x plus 1 equal to 0. splitting middle term x plus 1 equal to 0, 1 plus 1 2 and 1 into 1 equals to 1 into 1 1. So x common, x plus 1 common, x plus 1 equal to 0, x plus 1 equal to 0, x plus 1 equal to 0 or x plus 1 equal to 0. So x equals to minus 1 or x equals to minus 1. As we factorize by splitting the middle term as we were studying in the previous class, we can get the two factors of it, and when we transpose these factors, x is equals to minus 1, x equals to minus 1. So the zeros, the four zeros are, two of the zeros which are given to us, root 5 by 3 minus root 5 by 3, and the rest of the two zeros which we have calculated is minus 1 and minus 1. So that is our answer.